11E, it is software design, ethics, future plans, and conclusions.
So let's start with some background. At Lockheed Martin, keeping track of inventory has become a big challenge. There are so many projects going on, so it is difficult to know where everything is. So that's why Lockheed Martin asked senior project groups to develop a solution. So we first analyzed different products in the market. However, these products either don't meet Lockheed Martin requirements, are too expensive, or the internet connectivity which is not allowed.
So to solve this problem, we will design, build, and test a mobile computer station to manage current inventory more efficiently, and we will also develop and implement a semi-autonomous inventory system. And you can see like a picture of the current cabinets.
So here are the requirements for our StockTech Pro project. So as far as mechanical goes, it would be 3.5 feet in length and 3 feet wide. These dimensions are impossible just because of the turning radius in the facility. It also has to have height that must be adjustable depending on the user, and making sure that it's very adjustable depending on their heights. The station must be movable using casters and also lockable so that it's sturdy and won't be tipped over. And that must also support at least 100 added pounds or added components.
As for the electrical requirements, the device must have a power bank able to provide power to all the components in the mobile station for a total of 10 hours, because that's the part shift at Lockheed Martin. And then also only authorized users must have access to the load drivers that are going to have the computer and the different keys for the cabinets, and also super protection must be available to safeguard the power system. As for the software requirements, the database must be organized by programs and include all the description for the different parts and components, and also just the laboratory managers are going to be able to add or delete different programs or authorize users. And also parts of what is must be identified.
So moving into the mechanical specification, the frame of the mobile station will be fabricated using 1515 times 8020 aluminum profile. 1515 means the cross-sectional dimension of the bar, which is 1.5 inch by side. Also, it would have a 4-inch aluminum part, 4 locking wheels, and the monitor arm to allow raising and lowering of the touchscreen. The mobile station would have open spaces designed to place larger boxes on it, also arrows to facilitate movement, and drawers with restricted access.
So moving to the electrical specifications, we are going to use the Macedonia power bank to supply power to every component that we are going to use in the mobile station. We are going to use ESP32 for the lock mechanism, and we are adding DC breakers and switches to prevent from overload current and isolation from the power bank to the other components that we are using. For the software bank, we are using LabVIEW for the graphical user interface, SQLite for the database storage, and we are using Visa to manage the communication with the microcontroller.
This is the overall design of the mobile station, and it has different features such as the touchscreen, the barcode scanner, label printers, handles, drawers, and wheels. Important information of the mobile station is that the overall height of it is around 5.5 feet.
So here's the overall work breakdown structure for StockTech Pro. So first in the fall semester we went into project planning, and then we had the system design, which we created our mechanical, electrical, and software systems. And then we had to complete our fall deliverables. Next in the spring semester, we're going to be purchasing and manufacturing our products. We'll test our mechanical, electrical, and software systems, along with making sure that the whole system is compatible for Lockheed Martin. And then we'll tackle our spring deliverables. This is our schedule for just to make sure that it's very understandable for the audience. So first we went into project planning. After project planning, we had our system design. After system design, we tackled our fall deliverables. And then in the spring, we'll purchase and manufacture our electrical and mechanical components. We'll tackle our spring deliverables, and then we'll finally test. Here's our budget for StockTech Pro. Box in red are the Lockheed Martin supplied components, which would be the HV Ziva Firefly, the touchscreen monitor, and the barcode scanner. Comes to about $5,000 for total cost. For real-world budget considerations, so 4 engineers worked on this project, 8 hours per week, total 32 hours per week. Student pays $50 an hour. 15 weeks, it costs $24,000. For the licensing, for LabVIEW and SolidWorks, it would cost $67.50 for that price. Combined with the budget price, the Lockheed Martin supply, it would cost $85.79.54. Applying all these costs together is just south of $40,000 for the real world total budget.
Getting more in detail into the SolidWorks design, this is the unlock configuration of the mobile station. We could notice that the drawers and the back door is open. And important information about the SolidWorks design is that it was made by sub-assemblers, and it has 180 components. So in this part, I will explain a little bit more about this top table, and it contains the barcode scanner, the touchscreen, the arm-mounted touchscreen, which allows the raising and lowering of the touchscreen, and also the user could adjust the angle of the monitor, and the level printer. The space below these tables is to place lager boxes of 3 times 2 times 1 feet. This is a more detailed drawing view. We could see here the left drawer is to place the laptop. And we could notice that the button surface is a mesh to allow airflow into the drawers. So this also allows cooling of the laptop and avoid overheating. The right drawer is for the keys, and it has 32 compartments to place each key divided by project. This is a back side view of the mobile station, and in the right picture we could see the control panel to place all the electrical components on it. And in this left picture we could see that it has 4 handles to easily move the mobile station around the lab, and also wheels that could turn around 360 degrees to easily move this mobile station around the lab of Lockheed Martin.
So concerning the panel thickness, the main reason we chose to use a 4-inch thickness because the load per square foot is the least amount. This will allow that our system will be able to last for a long period of time. So to determine this final value, you have to find the section modulus. Then from this, you have to calculate the load P. And then from this, the load per unit width is found. And then after this, the load per square foot is multiplied and determined. And then this determines the panel material thickness. So given that thickness is about a 1/4 inch, their weight can be found by volume, potential density, gravity. This would be 0.743 pounds. And then the total weight and safety factor, knowing that mechanical, electrical, and max box weight, total weight is 377 pounds, and the wheels support 2,000 pounds each with 500 per wheel. Our safety factor is 5.3.
Okay, so now let's talk about the electrical design. So you can see here we have the general schematics. Starting from left to right, you see the 80,000 milliamps power power plant. That's going to connect to circuit protection. And at the top, you see the laptop. That's going to connect to the ESP. And then you have the lock mechanism. And from top to bottom, you see the reader, printers, and torque. And of course, in order to know the work bank, we need to do some power calculations. And we need to know the power consumption of every component. So this is a table that summarizes everything. So we need to calculate the power consumption for 10 hours of worship, and then we add 10% of safety margin in order so the power bank will not operate at the maximum rate. And finally, this is a schematics more in detail about the ESP32 connected to a relay and the solenoid blocks for the locking mechanism.
So moving into the software design, we have a full software over here. At first, we're going to have a login page. The user has to to search, to inventory, or to retrieve parts. And then also in the inventory part screen, there's going to be a text box where they scan the barcode in the part, or they can also just type it, and then they can inventory a part. And then in the remove part screen, they do the same thing like in the inventory part screen, but for removing the part. And then there are some actions just available for lab managers, like remove a program, also like add authorized users. And they can also print like a sheet table of all the low parts so they can use stuff. Where we have all the software design tools. First, LabVIEW. We are going to be using LabVIEW to design our graphical user interface. We're going to be using SQLite for our database. Since it is serverless, it is very lightweight, and it also has like built-in protection against like data loss. We're going to be the SQLite is going to hold all the parts, the information, all the user IDs, the names, and it's also going to say like if a certain person is an administrator or like a regular user. And then the DB browser for SQLite is just like the GUI for the database, because if we don't have DB browser, then we have to be coding through the command window. And then we're going to be using Visa, which is Virtual Instrument Software Architecture. It's a tool available in LabVIEW to communicate between LabVIEW and the ESP32. And then LabVIEW also has a toolkit called Database Toolkit to communicate between the database and LabVIEW. And then we also wanted to test this semester if our approach of using Visa was the correct one. And we just did a simple like push button in LabVIEW to control LED lighting up. And then we also tested the database connectivity. We just did a login page, and we had some user IDs and names in that database. We had a QR code, we scanned it, and it had a valid user ID, so it led the person into the program.
Now moving to the future testing plan, for the mechanical section, we're going to do finite element analysis and moving part testing. For the electrical section, we're going to do power plant performance testing and loop mechanism testing. And for the software, we're going to do functional usability and security and end-to-end testing.
So for the constraints, we are required to use LabVIEW. We are not allowed to include Wi-Fi or Bluetooth in the design, and we cannot exceed the $10,000 budget.
So the plan moving forward for next semester, so we'll tackle first or spring deliverables, make sure those are all complete. We'll purchase and manufacture our mechanical electrical components. As far as software goes, we'll program inventory management system. We'll implement this. We'll make adjustments based on your feedback from this presentation, and then we'll finally test all of our systems.
So for the conclusion of this semester, we mostly complete all the mechanical, software, and electrical design. We also tested the database and microcontroller connectivity, and we already have key components defined. And something to be mentioned is that we are on schedule.
We want to say thank you to all the Lockheed Martin engineers that helped us in the Engineering and Technology Department, and also to our advisor, Dr. Jones. Thank you. We are
What exactly is the nature of this stock that you're managing? I mean, what are they, bolts, nuts, transformers? Do you know what it is you're actually tracking with this system?
So we cannot know the exact information because we all have clearance, very international students, and we can't have clearance for work department, but we're going to get like parts that we can know about. So like they are going to fill out the database that we're going to implement like all the GUI and then like have tables made and all like the retrieving information into like the GUI and just printing and then.
Is your requirement that whatever it is, it has a barcode on it? Is that the key issue?
Yeah, and they're going to be like in boxes. So there are like boxes that hold like components on yeah, transformers.
So you don't know what the components are, but you know each one's in a box
Yeah.
with a barcode on it.
Yeah,
And
they
you know
are-
the size of the barcode enough, you know that it'll be scannable by the scanner you're using.
Yeah.
Okay.
You,
So it comes with a charge.
okay, so you ship it to the charger, right?
Yeah.
Okay, I didn't see anything regarding the charger or stuff like that. I guess those are all commercial. You just need to, I did because I didn't see that. Okay. That's part of the design. Okay. Secondly is that why do you think the wheels are the weakest part of mechanically? Why didn't you have any concern regarding other parts of the system? Why you just jump to the wheels are the weakest part of the system, not any other parts of the system? Like what's the, that might be right, but what's your conclusion? What's the rationale behind that? So about the wheels and the entire frame of the mobile station, we try to place every bar in a correct position to avoid most stretch into some horizontal bars. And the wheels, we're going to have wheels with a lock mechanism to make sure that the system or the mobile station doesn't move easily. So if a person wants to move the mobile station, then just unlock the wheel and they can move the mobile station wherever they want. And my question is, why do you think the wheels are the weakest part of the system? Why didn't you consider other parts of the system, like do a safety factor for other parts of the system? You see what I mean? Yeah. Why? Because the wheels is the most, for all these systems, or all the friendly wheels is the most risky. The material of the wheels doesn't support too much weight compared to the aluminum parts. So the answer is just gut feeling, right? Yes. Okay. All right. As a mechanical engineer, hopefully the gut feeling is right, but you see what I mean? You need to look at a little bit more scientific approach to the other parts of the system and have a general sense of why. You see what I mean? That might be true again, but your gut feeling may not necessarily always be right. Okay. All right. So final comment is that this system I see very small risk regarding the mechanical part, because mechanically you're not. It's not really good. The risk is very small. But I really want to suggest you guys have a plan for software testing. You need a very thorough plan. Otherwise, you have a whole bunch of blocks in there. The user would really feel that. So, like, it's a very much a software engineering project. You see what I mean? So you need to really kind of dig more into that as well. Software engineers, how they test the system thoroughly in a very comprehensive way, make sure no blocks, and it's not too many blocks. Otherwise, it can't work. I mean, it don't necessarily work so well. So you need to prepare for that, because this is very much a software engineering kind of project.
Yeah, I wasn't taught to like do debugging and computer science.
You need a comprehensive testing plan to dig up all the possible blocks, all the possible scenarios and the routes and the how to figure out how to fix all those blocks one by one until you get to the point you're satisfied. So it's that's something you must focus on.
In terms of limitational constraints, you figure out like what is the maximum number of parts that you can scan, or what are the boundaries?
So they give us a number. The max of parts I have is like 1,000 parts, and that just takes to like 200 kilobytes to the analysis. So it's not that much. So we can have like a lot of parts to the analysis.
In terms of the software, like if for some reason they want to update, or there is a product that they're not going to use anymore, how is it going to work that in your software?
So the administrator can, so in that way you can retrieve data from the database and they get like the status of the user, if it's a regular user or an administrator, and then if it checks that it's an administrator, then that person can either add or delete a program or a part for it from the database.
Thank you.